Okay, hello everyone. So, in the previous video, we discussed about ideal ramjet. Here we will see the effect of the aerodynamic losses, say due to the presence of shocks, etc. Say due to the shocks and irreversibilities in combustion, there is a slight deviation from the real ramjet. Slight deviation of real ramjet from the ideal case. Say for example, technically, the process of this compression should be an isentropic for an ideal ramjet. That is this P naught. Technically, my state 2 or the inlet to the combustion chamber should be here. But due to the loss of stagnation pressure, due to the presence of the oblique shocks, my P naught 2 will be slightly lesser than this. So my path will not be a straight line parallel to T axis, but it will be something like this, such that the pressure is reduced. Similarly, in the combustion, the like maybe due to the not fully combusted into products or something like that, or due to some other factors, this P naught, P naught 2 will not be constant, but it will go to some pressure, say P naught 4. And then similarly in the CD nozzle, there may be some heat transfer so that the process may not be exactly isentropic. So it will go to some pressure P6. And this P6 may not be equal to PA again. Okay, so we define few performance parameters called as say diffuser performance RD is defined as P02 by P0A. Combustive performance RC is P04 by P02 and nozzle performance RN is P06 by P04. Therefore, we define the overall stagnation pressure ratio P06 by P0A is P06 by P04 into P04 by P02 into P02 by PA, which is Rn into RC into RD. Now this PE is equal to P6 but not PA. Thus we can write this P06 by PE as R into RC into RT into P0A by PA into PA by PE. Now from this and this relation, from this and this relation, this P06 by PE is 1 plus gamma minus 1 by 2 ME square whole power of gamma by gamma minus 1. I'll get my Mach number at the exit. And then if at all I assume that the heat transfer per unit mass is negligible, like say it is an adiabatic process, like that heat transfer is very small, then I'll get this UE as something like this. Anyways, we are trying to find an estimates, not an exact values. So thus we get Mach number something like this, Mach number and U. And also there is some efficiency called as the combustor efficiency, which is due to incomplete combustion, which is defined as eta B. Which is eta B is the actual, which is the actual amount of energy released divided by the amount of energy that has to be released for a complete combustion. Now using this value of F, so instead of this QR, I'll just get eta B into QR, which is the energy released in the combustion. I think you can guess this easily. And then after finding this U, UE and F, you can easily find the thrust per unit airflow rate and TSFC. Now these are the typical values of RD, RB and RN. And usually, sadly, these are the functions of Mach number and angle of attack. But for a preliminary analysis, we ignore them. For the next video, I'll be discussing about a turbojet engine. And then later on, I'll be covering this turbofan, turboprop and turboshaft. Thank you.